Everyone, today we are in chapter 17, which deals a little bit more in depth with formulas and statistics. Today we're going to be looking at some basic fundamentals. We're going to be looking specifically at the difference between the mean, the mode, and the median. Now, what purpose do these serve? Well, when you're collecting data and you're gathering up all of these numbers and you're putting them together, how do you know the standard? What do you know would be the midpoint and the extremes between these numbers? Well, this is what the mean, the mode, and the median will be able to provide for you. We're going to take a look at some basic concepts such as the formula for the mean, and take a look also at what a standard distribution is. So let's go ahead and get started today with chapter 17, and we'll move on from there. Welcome back, everybody, and today we are in chapter 17, which is making the determination of sample size, and it's a review of statistical theory. Now, let me begin by saying I am by no means no statistician, and I'm not trying to make you one. What I want to try to do today and in subsequent chapters is just give you a basic idea of the maybe the terminology, the formulas, and go over some basic statistics for you that you'll be needing in business. But a lot of this stuff, when it comes to advanced statistical analysis, that's beyond the scope of this course. I'm going to teach you some of the basics, and this is where we're going to start today. Now, I'm going to go over this. You'll have in the next couple of slides more of a description of what we're talking about here, but with some graphs and some tables. But let's take a look at some of the basics. What are descriptive statistics? Describe characteristics of populations or samples. Maybe you're wanting to evaluate the sales revenue that your sales team generates, and you want to look at it, average it out over the last 6 months. That would be descriptive statistics. Inferential statistics is making inferences about whole populations from a sample. If I have, let's say for instance, if my sales team has produced on average $100,000 a quarter, then I can infer that a small segment of those salespeople would be making what in their contribution whatever's proportionate to what the whole sample would be. For instance, let me kind of describe this a little bit better. If I took all the salespeople from, let's say, AT&T, and I got a idea of how much they generate for AT&T each year. Well, I don't know if I could be able to go and talk to every salesperson at AT&T, but I could get a sample of people from AT&T, and what I could see are probably the same habits and the same performance that they make nationwide if my sample was random and it was unbiased. Sample statistics, these are variables in a sample or measure computed from sample data. And then population parameters, these are variables in a population or measured characteristic of the population. So we're looking at characteristics of the population. Are they male, female, different colors, ages, and so forth. Frequency distribution is a set of data organized by summarizing the number of times a particular value of a variable occurs. And we're going to take a look at that here in just a minute again. Then you also have percentage distribution, and that's a frequency distribution organized into a table or a graph that summarizes percentages associated with particular values of a variable. And again, we've got the graphs that are going to show these. Probability, and that's the long-term or long-run relative frequency with which an event will occur. So let's take a look at what we're talking about here. A frequency distribution. That's the number of people who hold deposits in each range. So frequency under 3,000, there are 499 of them. 3,000 to 5,900, that's the number of people within this range group, and goes from 562, 718 for 6 to 9,000, or 89.99, 9,000 to 11, 99.99, and so forth. So that would be a frequency. How many people occurred, or how many times did this occur for this range? So how many people really made this amount? That's really what we're saying here with the frequency distribution. Percentage distribution, you're just saying the same thing but in a different way. 16%, instead of an exact number of people, you're looking at the percentage of people here made under $3,000, and 26% made 12,000 or more. So you're saying the same exact thing, you're just representing it in a different way. And then probability, again, you're saying the same thing. Instead of 16%, you have a probability of 0.16 that they will make under $3,000. So you're looking at maybe some historical data, and you're making inferences based on what we've looked at in the past. There's a probability of 0.16 that under 0.16 will make under $3,000. So those are how they're represented. They say the same thing, but really they are just represented in different ways. Now your book talks about an average, and we're going to look at that here in just a minute. But take a look at the well-chosen average, and we may talk about that here in the forum today. But I want you to take a look at that. Average pay could mean there's a highly paid executive and many low-paid executives. So let's say, for instance, the president's making $100,000 a year, and the worker is making $20,000 a year. Well, that's a big discrepancy. And if I just took 100,000 and 20,000, 120,000 divided by 2 would be what? 60,000, wouldn't it? So that's really not going to give you a well-chosen average. The median may be more informative or so forth. But take a look here, and I just give you two numbers for the average. I mean, it's going to come out about the same. Even the median would be about the same. But take a look at the research snapshot on page 413, and we may talk about that in the forum for today. Now, making data usable. Now, when you're looking at statistics, and when you're trying to tabulate data, you have what's called the proportion. And the proportion is the percentage of elements that meet some criteria. And that's fairly straightforward. And they talk about that on page 412. And it says a proportion such as the proportion of CPAs at an accounting firm indicates the percentage of population elements that successfully meet some standard concerning the particular characteristics. So it's just looking at percentages of a characteristic of some property. Now, when it comes to central tendency, here we're looking at how close to the middle are people. Now, the mean, and that's what we're going to look at here at the bottom, is the arithmetic average. The median is the midpoint between the values in a distribution. So let's see if we can write on here. If I have a continuum and it's 1, 2, 3, 4, 5, 6, 7. The median would be number 4. That would be the midpoint. The mode is just the value that occurs most. If I had 3 1s, 2 7s, and everything else was the same, I could say the mode was number 1 because there's more of them. So that's the difference between the mean and the median and the mode. The mode is just the number, the value that occurs most often, and in this case it would be 1. Now the mean you see down here, and really in a nutshell what all of these symbols and numbers mean is that you take the number of instances, you add it all up and divide it by the number of instances itself. There's an example here on page 414 that shows you you've got an index of 8, which is what this I stands for right here. You've got the sum of the number of x's, and that's really what that means, divided by the number. So if you take a look here and you're following me, there are 8 people who made a number of calls, and the number of calls when you add it up is equal to 26. So you would have 26. Then you would divide it by the number of people who called, which is 8. And then they give you the number, or equals 3.25. So it's very simple. The sum of the number of x's divided by the number of people who, in this case, were in that call. And then you just translate it into numbers. Now, this here is the, excuse me, this is the population mean, and this is the sample mean. So you take it from the whole population, you can do it that way, or you could take it from the sample mean, and you're saying pretty much the same thing, or you go by the same criteria or the same formula. And I think this is what you have here. You have the same thing that we were talking about in the book. You have 1, 2, 3, 4, 5, 6, 7, 8. So n would equal 8. And if we go back, that's what we have here. N is equal to 8. And that's just how to go about it. You have the sum of n, you have n, the sum of the x's of n. I'll get it right in just a second. And from there, you can go 26 because you add all 8 up, divided by the number, which is 8, and it gets you that total. And that's what we have here. So 26 would be the sum. So it's fairly straightforward. All that is you take the total and divide it by the number of people, and you got your answer. And that would be, of course, the mean. Now, a range is a difference between the smallest and the largest value of a frequency distribution. So in a range, you have, let's say, here 1, 2, 3, 4, 5, 6, 7, 8, and the range would be this, from the smallest to the highest, and that would be the way of looking at a range. And we use ranges all the time, especially when we're looking at grades and looking at percentiles and so forth. We can use ranges in doing that, and that helps us out quite a bit. Now again, when it comes to the measures of dispersion, when it comes to mean, mode, and median, what you're looking for are statistical answers to questions that you may have. Now, this is just, as you'll see, just the very beginning part of some just basic statistics that we'll be taking a look at over the next couple of days. So this will be enough to start us off right now. I wanted to just introduce this one before we go into a standard distribution curve and z-scores and all of that stuff, and standard error of the mean and all of that. So for right now, that'll be enough, and we'll come back tomorrow and we'll finish up. Well, everyone, today we saw, again, just some of the basics when it comes to statistics. We saw how we average out things through the mean, the mode, and the median. And we also took a look at the formula for the mean. Now, we're going to be getting into some more formulas as we move along, so let's stay up to date on our reading and make sure that you are interacting in the forums. And if you have any questions, by all means, let me know. Give me a call or email me. Again, I'm not here to make you a statistician, but I do know that the more you are familiar with the basics to be able to tabulate research, the better off you're going to be. So we'll continue on tomorrow. So until then, you have a good day. God bless you. And we'll continue on with tomorrow's lesson that is a continuation of Chapter 17.